Okay, so then with that as an introduction, I want to talk about, we have, by this sort of final branch that I showed down here, we have created some interesting decisions that we have to make for ourselves, which are of our own evil making, but nonetheless, having made our bed, we have to sleep in it. And I want to just bring those up because they come out and bite you hither and yon. And that's called Rev 5 versus Rev 6, or being optimistic versus being pessimistic. We have two big systems, right? We have Rover and BOC, which look like this. There's a Rev 6 master, which runs Rev 6, and it's got the Winnie disk on it. And the Rev 5 slaves, which do all the image processing. They're N Rev 5 slaves, as many as you need, but at least one. Then we have Chrysler, which has only one system, and it runs Rev 6, and it has a disk. The reason why the communications are much, much better in Rev 6, and communication and file structure in general. So there's a strong desire to make this guy Rev 6.
DTaylor launches into a discussion of Rover's data structure and Gaging Exec. I wanted to point out a couple more differences on the Rev 5, Rev 6, Rover versus Chrysler. I think it's important, as long as we're trying to make something for the record, to tell why it is such a way. Rev 5 was required for the vision processing because of the John Agapakis laser line analysis. Multiple slaves were required in Rover due to cycle time restraints, and having multiple slaves and the need for SPC required a separate master. The master needed to go to Rev 6 because a Rev 5 master could not handle the communications load of several, these links right here. It was just impossible with a current Rev 5 communications bandwidth to be able to talk to more than one slave at a time, because this is very, very slow and has quite a bit of CPU overhead. There's really not too much reason why this couldn't have been a Rev 5 master if there'd just been a single slave.
What's different?
Seems there's a lot of things to discuss this morning. The first thing I want to touch on, since a lot of you aren't familiar with gauging in general, is the breakdown of how we've divided up the system into processes and results. I'm going to do that by drawing a little picture. The main processing units that both Craig's system and my system use is that we break up the system into locations, windows, measurements, computed gauge points, and features. And I'll explain each of these in a minute. I'll let you use that. Okay. The largest processing piece, which is an encompassing processing piece, is called a location. And a location can be visualized as the popsicle stick which a module is placed. And the module is various or sundry types of units that are manufactured, where we have some with laser dots, laser lines, infrared dots. There's quite a spectrum of different gauging tools that we can use. The module is, as a rule, a combination of two cameras, or a camera and a structured light piece.
Historically, and coming on to Chrysler, the intent was to use Austin Rover code as much as possible, which I think we've done reasonably well. So what I'm going to go over is a discussion about the Chrysler exec, and talk about where it deviates from the Austin Rover. To start out, I thought I'd just do a quick drawing just to show terminology here. Letting this be a module, this can be, let's say, just an arbitrary part you want to gauge. In talking about location, this would constitute a location. This would constitute a measurement. You want to locate the XYZ of this hole. This would be the two windows associated with calculating that measurement. And this, for example, could be another measurement. and the computed gauge point, they might be interested in the distance from this hole to this one. There's also 3 coordinate frames represented here. This is the offline calibration coordinate frame. This gives you the world to pixel and pixel to world for just a standalone module. This is the online calibration target coordinate frame, which gives you the coordinate frame for the surface, basically of the nominal feature. And this drawing, this would be your body line coordinate frame, which tells you that's the coordinate frame that the parts, the prints